All right, chemistry, as we continue our review of semester 2 chapters, we are in chapter 15, and we're continuing our discussion about acids and bases. And specifically, we're going to be looking at how to do some calculations to find pH, to find concentration, as well as have a conversation about titration. Okay? One thing that you definitely have to remind yourself is that water, even though it is a neutral solution, it does go through to a certain extent, self-ionization. What that means is water will donate to itself an H+, and you are going to create, as a result, your hydroxide ion and your hydronium ion. So one of the waters will donate an H+ to another water molecule. The first water molecule then turns into hydroxide ion. The second water molecule turns into hydronium. This is what is called the self-ionization of water. It happens to a tiny extent, but it still happens, and you need to be aware of it. Okay? We are going to look at how we are going to calculate these four values: pH, pOH, concentration of hydronium, concentration of hydroxide. Given any one of those, you need to be able to find the other three. All right? We'll talk about what it means to be acidic. Basically, if a solution has more hydronium ions in it, the concentration of hydronium ions is higher than the concentration of hydroxide, then it's acidic. Basic, if the concentration of hydroxide ions is higher than the concentration of hydronium, then it is considered basic. A titration, if you remember, we're adding a base to an acid or an acid to a base, and we are going to get to a point, we're trying to get to a point where we know that they've neutralized each other. When we get to that point called the end point, we know that the moles of the acid that you added, or actually it's the moles of the H+, the hydronium, have to equal the moles of the hydroxide. And when that's true, to find moles is molarity. Concentration times volume gives you moles. So this would be for the acid. And over here, this would be for the base. We can set those two equal to each other and then find an unknown value. So you might be given the concentration of the acid used in the titration. You might be able to find the volume of the acid that gets you to the end point. You might be given the volume of the base that gets you to the end point, and then have to find the concentration of the base, for example. Okay? Let's go back and look at some of these problems here. Most of these are going to be dealing with concentrations and pH and pOH. The hydroxide ion concentration of an aqueous solution is this. What is hydronium ion concentration? Let me just remind us how we can move from one of these to any of the other three. Okay? Given any one of these, you should be able to move to all the other three. If you have the concentration of something, to go to pH, you would take the negative log of that concentration. Oh, sorry, that's a negative there. Oh, sorry, that is actually a plus there, my fault. Okay? So, same thing down here. If you know the concentration of hydroxide, you would take the negative log of that to get the pOH. So P means negative log of some concentration. So the pOH is the negative log of the hydroxide ion concentration. pH is the negative log of the hydronium ion concentration. So to go the other direction, you would take 10 to the negative pH, and that would give you the concentration. Here, we would take 10 to the negative pOH, and that would give you the concentration. Okay? So now we want to figure out how we go between pH and pOH. To go from pH to pOH, these two are always going to add up to 14 in an aqueous solution. So that's easy enough. If you know one, then you know the other. If you know pH, then you just take 14 minus pH, and that will get you the POH. 14 minus POH will give you the pH. And the two concentrations in an aqueous solution, their product is always 10 to the negative 14. So if you know one, you know the other. If you know hydronium or hydroxide, you just divide the known value into 10 to the negative 14, and you got the other one, okay? Okay. So you have to be very comfortable with these four values and being able to move between them, okay? So let's look at a simple example. The hydroxide ion concentration of aqueous solution is this. They give you the hydroxide. What is hydronium? So they're giving you the hydroxide. They're giving you this value down here. They want to know the hydronium. Take 10 to the negative 14, divide by this given hydroxide concentration, and you've got the hydronium up here. Calculate the hydronium and hydroxide in this concentration of HNO3, a strong acid. Well, they're telling you it's a strong acid, so any strong acid is going to completely dissociate. What does that mean? This HNO3 is going to completely dissociate into H plus and NO3. So one of these is going to create one of those, and it's also going to create one of the NO3, but we really don't care about the NO3. We're looking at the H plus, or the hydronium ion. So it's a 1-to-1 ratio. So if they're giving me the concentration of the HNO3, if this is 7.5 times 10 to the negative 4, then that's going to create the same amount of H pluses, or hydronium ion. Okay? So they are, in essence, this is only true for a strong acid or a strong base. A strong acid completely dissociates. So they're giving me the concentration of the hydronium ion right there. So I've got this. Remember, H plus is just short for H3O plus. And then, so they give me this by telling me the concentration of the strong acid. And now to find the hydroxide, I just go and I take this known value here, and I divide that into 10 to the negative 14 to get my hydroxide. Okay? Determine the pH of that concentration of HBr. Same thing. This is a strong acid. So by giving you the concentration of the HBr, they're giving you the concentration of the H plus, the hydronium right here. And all you need to do is take the negative log of that concentration. Okay? What is the pH that has a hydronium ion concentration of 1? All right? Hydronium, they're giving you this value, and they're telling you it's 1. The pH, you would take the negative log of 1. Hopefully that's a quick calculation for you. All right? What is the pH of a 2 molar solution of HCl, assuming the acid remains 100% ionized? So strong acid, that's going to completely ionize. The solution of the acid is also going to be the solution of your H plus, or your hydronium ion right here. So to find the pH of that, you just take the negative log of 2. Okay? Theoretical pH of a 10 molar solution. So a 10 molar solution, that's really, really concentrated. Assuming that all dissociates, it may not, but assuming that all dissociates, again, you're just going to take the negative log of 10. I reiterate, this can only be done with strong acids. The solution concentration is going to be the same as the concentration of the hydronium ion for strong acids, and for strong bases, it will give you the same concentration of the hydroxide ion. Okay? If we come down here, let's look at some of these. What is the pH? This is hydroxide ion. So if you're given hydroxide, they are giving you this here. So you have a choice. You can take the negative log of that concentration and find the POH, and then subtract that from 14 to find the pH, or you can take 10 to the negative 14 divided by the given hydroxide ion concentration. That gives you hydronium ion concentration, and then take the negative log of that to get your pH. You can go either direction. You should maybe try both directions and feel comfortable with each of these concentrations of hydroxide ion. What are the POH and hydroxide ion concentrations of a solution pH of that? So now they're giving you the pH, they're giving you this value. You need to get to here, POH, and then you need to get to the hydroxide ion concentration. You need to go to here. So you should be able to do that now. What are the POH values of the solutions with the following? Hydronium. So now they're giving you this value here, and you need to get down here to POH. You can choose the route. You can go to pH and then to POH, or you can go to hydroxide concentration and then to POH. Your choice. Okay? Uh, 424. Okay. A solution is prepared by dissolving 3.5 grams of sodium hydroxide in water and adding water until the total volume of the solution is that. What are this and this? Okay. They're basically giving you information so that you can find the concentration. They're not telling you the concentration, but you can find it. So, you're taking this mass of sodium hydroxide. Sodium hydroxide is going to dissolve into its ions. It is a strong base. And you've got 3.5 grams. So what you need to do is you need to find the concentration of that sodium hydroxide by converting it to moles per liter. It says the total volume, they give that to you. So basically, you've got grams per liter. You need to change that to moles per liter by dividing by the molar mass of sodium hydroxide. You got to figure that out. So now you're going to have the concentration of your sodium hydroxide. That's going to be the same as the concentration of hydroxide. Okay? So now you've got the concentration of hydroxide, and once you have the concentration of hydroxide, you should be able to go to the concentration of hydronium. Okay? And 425, if 1 liter of potassium hydroxide solution with a pH of that is diluted to 2 liters, what is the pH of the resulting solution? Okay, so basically what you need to do here is you are given volume and you're told the pH is a certain amount. Okay, so pH, if you remember, is the negative log of the concentration of the hydronium. Okay? So, if the pH is 12.9, you should be able to find the concentration of the hydronium ion. Basically, it's going to be 10 to the negative 12.9. That's going to be the concentration. Okay? Now it says, and this would be in moles per liter. Oh, I need to back up. Okay, no, that's okay. We're okay. Okay? That's the concentration of hydronium. Okay? From that, you could find the concentration of hydroxide. So if you take the concentration of hydroxide, then is going to be 10 to the negative 14 divided by this number. And then once you get the concentration of hydroxide, that was for 1 liter. Now it says you're going to dilute it to 2 liters. So basically, you're going to have the concentration. You're going to dilute it by doubling the volume. So now you're going to take this concentration right here, and now it's no longer for 1 liter, it would be for 2 liters. So your concentration that you find here is basically going to be divided by 2, and you would find out that it's half of what it was before. Okay? Once you find that concentration, I think I kind of went a long ways here, but once you find that new concentration, then you can work back to get the pH of that new solution. Okay? All right. Let me know if you got questions. Check your answers here, and let me know if you need any assistance.